Good morning. So let us continue our lesson today before we go on with the tutorial. Today we're going to start with Bayes' theorem. So look at the example here. Have a read first on this example. In a certain assembly plant, three machines B1, B2, B3 make 30%, 45% and 25% respectively of the products, which means the product being done in the machine B1, probability the product is done in B1 is 0.3. Probability of the product done in B2, machine B2, 0.45. Probability the product is being done in machine B3 is 0.25. It is known from past experience that 2%, 3% and 2% of the product made by each machine respectively are defective. So if the product is done by B1, it is defective. Defective, I put an A here, is 0.02. The product is done by B2 and it is defective, I put here 0.03. The probability that it is given done by B3 and it is defective is 0.02. So these are the information we get from this question. Now if a finished product is selected randomly, what is the probability that it is defective? We want to find what is the probability of defective. Okay. Now as I told you before, you want to find the probability for a single event. What you need to do, you have to plus all the joint probability related to that event. So here I can see B1, B2, B3. So I'm going to, for me to find the probability of A, which is defective, I need to plus all the joint probability related to A. So this is what we are going to do now. Okay, we are going to find what is this, what is this, and what is this. Okay, but then how to find, let me show you how to find this one. This one, if I want to write say this is the main Okay, now how am I going to find this one, We know that P is equal to PB, and if I multiply this here, my PA so if I want to find the joint probability between A and B1, I need to multiply probability of B1. What is probability of B1? 0.3. Probability of A B1 0.2. Multiply, I'm getting 0.006. So I give you some time now. I give you some time. Find me what is this, and find me what is this. Use the similar method. By similar method, by similar method, find me what is the other two thing. I just give you some time. For those who came late, you want to copy this, copy here, copy and find me the thing. Sorry if it is too small. It just, yeah, okay. From here you can copy and try find me the other two. if you notice, if you want to find the other two, is you will get 0.0135, 0.005. So the answer is, if I want to find the probability of defective, this is the answer. Now if you notice, of course in your slide I think there is something you need to write. So if you I think in view of, yeah, I think in your slide you need to copy this. Whatever I have written here is almost is the same thing. Okay, if you want to copy this, you can also copy this in your slide. There's empty space for your slide. I think you copy this, all this, if you want. But whatever I've written here also is the same thing. Okay, I give you some time. If a product were chosen randomly and found to be defective, what is the probability that it was made by machine B3? You see, previously what this question is asking is, if the product were chosen randomly and found to be defective, it is defective. It is defective. What is the probability that it was made by machine B3? Previously, A, defective is A. See, previously we have this information, okay, A, B3, but now what we have to find? The other way around. We have to find B3A. This is where the Bayes formula comes and help us. Okay, so Bayes formula is basically, if you are given, for example, given B, A, and from this information and some other information you want to find the other way around, given A, B, here you have to use the Bayes formula. Okay, so let us see how we do these things. So I want to find B3A, if B3A what I can write here is, I can interchange these. Okay, but then this one we already know the joint probability. See, the joint B3 intersect with A, and the probability of A intersect B3 is the same thing. We already found B3 A intersect of B3 is this one, 0.05, 0.005. And what is PA? Just now we found the PA. PA was 0.0245. If I do this, 10/49, this would be my answer. We copy this. You can also, if you want to, you can copy this also. But before that, I want to show you something here. So I told you I'm using Bayes formula. The general Bayes formula is like this. So this part here, of course you don't need to write. This is sufficient for you to do the exercise. If you understand this, that is sufficient. But basically, what is A B3? A B3 is actually and PA. This is PA. This is how we find PA just now. Remember? The formula looks complicated and long, but if you do exercise, you don't need to. You will get used to it later on. So basically, this is your Bayes formula. Now next example. Don't worry if you cannot copy everything in the video, and I'm going to share the slide, the notes. Example 2. Read the example 2. A manufacturing firm employs 3 analytical plants for the design and development of a particular product. For cost reason, all 3 are used at varying times. In fact, plan 1, 2, 3 are used for 30%, 20%, and 50% of the product respectively. The defect rate is different for all 3 procedures. there are three analytical design. So the probability of the product done by plan 1 is 0.3, 0.2, 0.5, and given that the product is designed by plan 1 and it is defect, the probability is 0.01. It is given there already. If a random product was observed and found to be defective, okay, they now the other way around, as I told you, Bayes' theorem is to find the other way around. If dp1, then we are going to find the dp1 and d. Okay, if in this case, what we are going to do, if a random product was observed and found to be defective, it is defective now. Okay, which plan was most likely used and thus responsible? So if it defective, okay, random product is defective, what would be here? Which plan will be here will give you the most highest probability. Okay, highest probability. Which product which plan will give you the highest probability? Is it P1, P2 or P3? So we have no choice. We have to find P1. What is P1? And then P2, and then P3. We have to find all, and the probability with the highest value is the plan which gives the defective product. Okay, so for me to find this one, okay, let me use this color, P, this one. I need to find PD. But what is PD? PD is the joint probability of with all the related plan. So and as I told you, the similar method to find this. Okay, PP1 is 0.3, and DP1 is 0.01. if you find this one, you will get 0.003. And the same method, can you find me what is this one and this one? I give you some time, find me the one. If you find this, you will notice you will get 0.006. This one you will get 0.006. So once you find this, your PD is this is your PD. Here I have given the before this before I show my slide, let me show you step by step. So this would be your PD. What would be your this one we have found PD is done. PD is done. Now we're going to find this one. This one is P intersect D is exactly same with D intersect with P1. This one. Okay, this is same thing here. So if I want to put the value, this is the probability for the it is defect but from plan 1. Okay, this is one method, step by step method for you to find. Or you want to copy this also can, the same thing. Okay, you just put all the formula inside there. Okay, just now we find this one, just now we find one by one, this one we find, and then we find this one, and then we do. But if you want to do one shot also can, you can copy this if you want. I give you some time. Alright, so similarly if you notice here, okay, so for similar method, so what we have done here, P1 is this one, and if you use the same method to find P2 and D, you may end up with okay, these two. You can try by your own, take your time and try this one. So out of this, which one is highest probability? Okay, which one is highest probability? This one. So the answer is this one here. You can see the answer here. Later on I will share this slide also with this all these answers. Okay, don't worry. So I will put it there, slide with complete answer, something like that. The word complete is there. Okay. So the conditional probability of a defect given plane 3 is the largest of the three. So that's defective. If a product is defective, so most probably, most likely, it is from plane 3. Okay, this is the idea. Now let us move on to the next example. Read first. Now let us go to the example 3. Yeah? In Orange County, 51% of the adults are male. The probability of M is. It is announced that a survey will be carried out, and later learned that the selected survey subject was cigar, smoking cigar. The subject is cigar. Okay, so those who are smoking cigar. Also, 9.5% of males smoke cigar. Given they are male, their smoking cigar is 0.095, whereas 1.7% of females smoke cigar. If male is 0.51, then female is 0.49. Use this additional information to find the probability that the selected subject, what is the selected subject? Cigar. Given the person is smoking cigar is a male. Okay. So as usual, this is equal to, okay, I give you some time, try to answer this. I give you some time, try to answer this. This would be the last example, I guess. After that we are going for exercise. I give you some time, you try try to get me the PMC.
Doctor, I think your mic is turned off.
Yes, actually I know my mic is turned off, and yeah, I'm aware of that. Thank you anyway. Thank you for telling me. Normally, sometimes I don't talk.
Alright, doctor.
Sometimes I just don't talk. I just write. After I write, I will explain. Anyway, don't worry. It's okay. No problem. Thank you. Thank you. Anyway, thank you. Hope you guys get this is your probability of SIGA PC, and this one is same with this one. So the answer is actually I give you here 3 decimal places, isn't it? Doesn't matter. You can give 2 decimal places. Give me at least 2 decimal places. Okay. So I hope you all of you get this answer. If you get this answer, that is good. And you can see here I also give the full answer here. This one there's a typo here. This is not this is not PD P1D. I forgot to change. This one is MC. Yeah? You want to copy this also? Can you copy this? All right. So this is all regarding Bayes formula, problems regarding Bayes formula. Hope you guys get the rhythm, get the idea how to do this. All right. So basically this is the general formula for Bayes formula here. Okay, regarding the exercise, I'm not going to do each and every exercise here. What I will do, I will upload the full answer. Okay, I have the full answer for exercise 1 till exercise 5. I will upload in the group. You guys go through the answer first, or you want to try first and check the answer first. Okay, in that case we can finish the syllabus a little bit faster. So that's all regarding first chapter. The first chapter probability is finished. Later I will upload all the materials including the complete slide and the notes. Okay, the notes which I write here. All right, now now we are going to go through some exercise on a tutorial. Normally how the tutorial will go is, the question I will ask you all which question you want me to do. Okay, but before that, yesterday a student asked me how to identify the conditional probability. Of course it is quite difficult because of the wording in the in the question. But before that, let me open the tutorial. Okay, join marginal and conditional probability. Okay, because since a tree diagram and Bayes theorem we just finished, so you may not done the second part of the tutorial. Okay, so we focus on the first part. Okay, before you guys give me any question, let me explain what the student asked in the last class. I just give some simple example here regarding conditional probability. Yeah? Basically, you see, even though today we start with chapter 1 probability, and let's say I have started chapter 2, chapter 3, chapter 4, and we are doing all that kind of tutorials, doesn't mean that you cannot come back to chapter 1 and ask me the question. No. Okay, you can ask me any question from any tutorial. Okay, it doesn't mean that today we do chapter 1 and maybe after 2 weeks we do chapter 2 or 3 tutorial. Doesn't mean that you cannot ask from chapter 1. You can ask, still can ask. You feel free, ask any kind of question from tutorial, doesn't matter. Okay, I'm always prepared with my things. If I'm not prepared, then I will ask you some time and I will post it in the group. So we have flexibility and convenience in communication and learning PNP, the teaching and learning process. So don't get too stressed and all this thing. You can ask anything anytime you want, but if I can answer immediately, I will do it. Otherwise I will do it later somehow. Okay, now conditional probability. Yesterday a student asked me how to identify which one is given or which one is not given. So for that, let me give you one simple example. Okay, let's say there are 10 students in a group. Let's say there's a 10 student. Student 1, student 2, out of 10 student, okay, this is in one class, 10 student, let's say this student have let's say this student have curly hair. Student 4 curly hair, student 6 is curly hair, 8 is curly hair, 10 is curly hair. Maybe let us put S1 also curly hair. Okay, now out of these curly hairs, the rest, maybe let us put they're having they wear spectacle, and some curly hair student also wear spectacle. Alright, something like that. Okay, hope you guys get my point. In a class there are 10 students. Out of 10 students, how many of them curly hair? 1 2 3 4 5 6 students. The red color is curly hair. And how many of them wear spectacle? 1 2 3 4 5 6 7. And how many of them have curly hair and also spectacle? 1 2 3. Okay, the green color is wearing spec, the red color is curly. All right, if I ask what is the probability of curly hair, then then you take the total student, your sample size would be the total student, 10, and then you choose all the student with curly hair, 1 2 3 4 5 6. The answer is 3/5, or you can also write 0.6. Okay, now let's say I want to find the probability of wearing spectacle. Then that would be 1 2 3 4 5 6 7, isn't it? Yeah, 7/10. Your sample size is still 10. Sample size, I'm looking, you see how we define the probability. Out of 10 student, my focus is all the 10 student. That is my sample size. Out of these 10 student, how many of them are curly? 6 of them. Now again, for spectacle, out of 10 student, how many of them are wearing spec? 7 of them. So it's 0.7. You can write it decimal, you can leave it as a fraction. Now let's say we put conditional probability. Given the student is curly, what is the probability of he is wearing spec? Now you must understand that your sample size is not all the 10 students. Your focus is now, or your sample size is now only your sample size is now only those with curly hair, the one behind, given curly hair. So when you read the question in the tutorial, you must identify where your focus is, who's your sample actually. So in this case, my sample, I only look at those who curly, which means my sample size now, how many of them are curly? 1 2 3 4 5 6. My sample now 6. Out of these 6 students, the curly 1 2 3 4 5 6, how many of them wear spec? 1 2 3. Answer is 1/2. Hope you guys understand this. Okay, this is one way of doing conditional probability. Of course, the formula for this is this one. Okay, you can follow the formula if you want, but a quicker way to analyze this kind of conditional probability is as how I did just now. Okay, I only focus on curly student only. My sample is not all curly student only. Out of curly student, how many of them were spec? Okay, so you have to identify who is your respondent, who is your sample size, where is your focus, from which object, who are your students, out of who you are looking the characteristic. Now if I change little bit, given they are wearing spec, what is the probability he is also wearing he is a curly hair. So who is my respondent now? Who is my sample? Those who are wearing spec. How many of them wearing spec? 1, 2, 3, 4, 5, 6, 7. Out of 7, how many of them are curly? Again, 1, 2, 3. So the probabilities change, you see. This one we won't get a nice number, nice decimal number. Just leave it as a fraction. Okay. Of course, if you look at the the formula, it looks like this one. Okay, so this hopefully you guys understand how to get the idea and all these things. Okay, so so this is the explanation for the student who asked me in the yesterday's class. Hope you get my idea on this. You have, yeah.
Sorry, but for the last equation, C or P?
Oh, C is P. Sorry. Okay, thank you. All right. So, I normally want to finish the class is 1.5 hours because 2 hours is too long for me sitting in online class. But I can do maybe 2 or 3 questions. That too, if you want to ask me anything. Any question you want me to do, anything, which question you feel difficult, let me know. As I told you, because we start today with a lesson, we cannot immediately start with the tutorial. Don't worry. Anyway, we still have time and we can proceed all these things. But if you guys want me to do any question, let me know. Yeah.
Can you show me for the question number
8?
Yes.
Determine whether the events are independent from the following joint probability. Yeah, somebody is actually you no need to raise your hand. You can immediately open the mic and talk to me. But let me do number 8 first. Determine whether the events okay. So they give you in frequency and you want to the frequency. Normally we want to find the probability, isn't it? Joint probability. So what you do, you change it to probability. So what is total is how much? Total is you plus all the frequency. This is 7, this is 13, total is 20. So the probability of this one is 4/20. That will give you 0.2. Okay, we focus on the probability, and A2 is 3/20 will give you 15. (12/20) and 0.05. So first we find the probability, and then if you want to show whether the events are independent or dependent, you have to do, if you compute this, you will get 0.2. I hope I don't need to write all. Let me write one. Joint probability of A1 B1 0.2. The probability of B1 is 0.8. Is it B1? Oh no, B1 is this side, 0.35, and you will get 0.58. And what is the probability of A1? 0.8, isn't it? And you see these this is not same, isn't it? Therefore event A1 and B1 is dependent. This is for even A1 B1. Okay, so what you have to show, this is the first part. This is the first part. And if you notice, for second part, after this, after A1 B1, you have to show that it is this one also. If you compute, the computation has how I do here, A2 B1 is also not equal to this one. So let us finish with A1 first. A1 B2 is also not equal to A1. So you can see that again the same thing, even A1 and B2 is dependent. For third one, what to do? Same thing, do for A2 B1, show that it is not equal. Of course, if you compute you will get a different answer. Okay, if you get same answer, then it is independent. Now even A2 and B1 is also dependent. You might ask me how I know it's not equal. You compute and see, you will get a different answer. And the fourth one is A2, B2. You have to consider all the combination, and even A2 and B2 is dependent. So basically once you write this one, just enough, that's all. Okay, that's how you answer. Basically the events are dependent, all the events are dependent actually. That's how you answer this question.
Doctor,
Yeah,
how to know the table is the frequency table?
the frequency, this is frequency 4
Because
3.
the number is even number.
Yeah, if it is just a number, and this one cannot be probability, because probability is must be 0 to 1, isn't it?
Yes, yes.
So if it is given a number, then it is a frequency actually.
Oh, alright. Thank you, Doctor.
Okay. All right, guys. I think I want to stop here. We will continue anyway. Don't worry. We will continue, and we will continue this tutorial in our next week. You keep doing. Hopefully, you get the answer. If you cannot get the answer, then you can ask me. Always can ask me in any tutorial. Doesn't mean that only next tutorial. Any tutorial you can ask. Okay. I will make sure I will finish maybe a certain chapter 1, chapter 2, chapter 3, the tutorial, before I give you the test. Okay. So with that, thank you very much today for attending my tutorial. I will upload and share all the thing in the group. Okay. You can also ask me in the WhatsApp, in the group. You don't need to ask me personally. You just put whichever question you don't know in the group, and maybe I will answer also that one. Okay, if you don't know. So feel free to communicate in the group. So that's all for today. I'll see you all next week. Enjoy your holiday. Tomorrow is probably holiday, isn't it? Yeah. So thank you very much. That's all. Take care. Bye.
Doctor?
Yes.
Doctor?
Yes, yes. Hello? 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 Yeah, who's that? Hello?
Doctor, can you hear me?
Yeah, I can hear you.
Okay. Doctor, my question for the number 8, right? Since
Yeah.
they asked whether the events are independent, does it mean we have to show the calculation for all the combinations?
Yeah, all the combination. Unless they ask for specific. If they ask, even determine whether A1 and B1 is independent, then you do A1 and B1 only. If they ask whether events are independent from like this, normally in the test or final, I will put a specific event. I won't do like this. This is just for your practice.
Oh, okay. Thank you, Doctor.
Okay. Any other questions?
Doctor, can you share our RPP?
Yeah, I'm doing that. I'm preparing that. Don't worry.
Alright, thank you.
Okay. All right. I think that's all for today. I'll see you guys next week. Take care then. Bye bye.
Okay, Doctor. Thank you.
Thank you, Doctor.
Thank you.